right, in this video, we're going to take a look at finding areas of trapezoids, rhombi, you can also say rhombuses, or kites. So I'm going to do a quick overview of how we get the formula for trapezoids, and then we'll just do a quick example of the formula for rhombi and kites. So here's a trapezoid. Remember, a trapezoid has four sides. Two of them are not parallel. We call those the legs. Two of them are parallel. We call them the bases. So here I have base one up top, base two on bottom, and the height is that perpendicular distance between them. To find the area of this thing, we can think of divide and conquer. So if I was to take that base and split it into x, y, and z, whatever numbers those might be, and then if I could find the area of each part, like that blue triangle that has a base of x, the green triangle with the base of z, and then the red rectangle, which has a base of y, then if I add those areas together, I should get the area of the total trapezoid. So looking at those formulas, 1/2 xh, yh, and 1/2 zh, because for triangles, 1/2 base times height, and for rectangles, base times height. Now, if you take a look at that expression, notice they all have an h in them. So if you add those together, you could actually then factor an h out. So I pulled one h out of each of those expressions there. On the inside of those black parentheses, if I take a look, I almost have a half for each term, but not for that middle term. So what you could do is think of 1y is 2 times half y. Oh, now I have a half on each term. Now I can factor a half out of each term. And then I have a half on the left, an h on the right. On the inside, I have x plus 2y plus z. X plus 2y plus z, that almost looks like base 2. Base 2 would be just x plus 1y plus z. So let's take 2y and just write it as y plus y. That's the same as 2y. All right, so I still don't quite have base 2. And you might wonder, why do you want base 2? You'll see here in a second. If I change the ordering of that x plus y, you can do that because when you add things, it doesn't matter which order you do them with real numbers. So now I have y plus x plus y plus z inside of those parentheses. So 1/2 of all of that times the height. But then we said a second ago that x plus y plus z, that's the entirety of base 2. Also base 1, if that red part is a rectangle, base 1 is just plain old y. So you can generalize this to say 1/2 parentheses base 1 plus base 2 close parentheses times height. This is your area formula for a trapezoid. So the different things that you need both bases and you need the height. If you don't have all of those things, you cannot find the area of a trapezoid. So for example, let's look at this trapezoid here. We can easily see that the bases are 10 and 15. The height, though, we do not have. You might be tempted to think that it's 13. That's a leg length. It's not the height length. So what we might do is draw in a perpendicular and then use Pythagorean theorem. So I can chop that bottom base to a 10 and a 5. Using Pythagorean theorem, you should notice that triple, 5, 12, 13. So the height is actually 12 feet. And then if you plug into your formula, 1/2 base 1 plus base 2 times height, that should end up with 150 square feet. So that's one example of a trapezoid area question. To find the area of a rhombus or a kite, the formula is slightly different. Instead of adding bases, we're going to take the diagonal lengths, multiply those together, and then divide by 2. And I'll show you some examples of why this works out in class when we meet up next. So let's say I have this rhombus below. So that rhombus has a length of 18. That means every side length is 18. That 60-degree angle, I can use 30, 60, 90 triangles to then identify 9 and 9 square root 3 as those lengths. That means that one of those diagonals is 18. The other diagonal is 18 times the square root of 3. If you remember those properties of diagonals of a rhombus. So plugging all of that into my area formula, 1/2 diagonal 1 times diagonal 2, looks like I should get 162 square root 3 yards squared. The same would be true for a kite. It's the same exact formula. You need to know each diagonal. That should get you enough information to get a head start on those questions over 11.2.